Hi and welcome back to another LeetCode problem. Today we are continuing to go through the heap priority queue problems on LeetCode.io. We are going to have a look at the task schedule problem, which is rated as medium. And this problem is about, well, first it's LeetCode 621, the task scheduler. And this one is about a scenario where we are giving a CPU and we're giving tasks for that CPU. Each task has a certain label, a letter between A and Z, and we're also giving a number n. Now, we can execute any task in any order on the CPU, but there's a constraint that says that if we computed task A on the CPU, we have to wait n cycles before we can compute it again. So here's an example. We're giving these tasks 3 times A, 3 times B, and we're giving the delay, I guess we could call it a delay value of 2 before we can reschedule the same task again. Now, here's an explanation. A possible sequence is A, and then we cannot schedule A again because we need to wait after scheduling A for at least 2 cycles in which we can do other work. Now, since we only have one other task type, which is type B, we can execute tasks of type B, but then we have to wait 1 cycle since we're not allowed to run task A again. And then we can run task A. And by that time, B also waited 2 cycles and we could run B again. And this pattern repeats. And what we need to return is the total number of cycles to, well, compute all of these tasks, which in fact, the requirement is that we're going to return the minimum number of CPU cycles or intervals required to complete all tasks. Something we could also do is we could just execute task A, wait 2 cycles, then task A again. So that would also be a sequence of completing all of the tasks, but it's not going to be the one that does it in the shortest amount of time as seen here. Here's another example. This time we need to wait only 1 cycle between executing the same task again, and we're giving the input tasks A, C, B, D, and A and B are twice. Now we only need to wait 1 cycle between executing A and A again, but we might want to choose a different task, even though we could schedule A right after B again. So how can we deal with this? Well, we need to establish some kind of ordering in which that tells us which tasks we can run next. And for this type of problems, it's usually the natural thing to go to is to use a heap, because a heap allows you to pull out the next smallest or the next largest element from a set of elements. We don't really care what are all the tasks that we can execute right now. We just need one, and it doesn't matter which one. So in this problem, what we're going to do is we're going to have a queue. We will use a heap for that. And in Python, you can import a built-in, well, a heap queue from heap queue. We're going to import, well, heapify. That is the O of n method that can turn an array into a heap in linear time. But we're also going to use heap pop to move elements or to extract elements out of the heap. In Python, a heap is always a min heap. There is no max heap, which for this case, it's fine. We want to put items in there ordered by their next execution time. And what we're also going to do is we're going to, well, we need to figure out, if we have 3 times a task of label A, how do we figure out when we can run that task? Well, you could think of it, you could think of it this way. If you have a task A 3 times, right? And now we know that at T0, we can execute that task. If we have a task B twice, we also know that we can also execute task B at T equals 0. Now, if we say that n is equal to 2, then when is the next time we can run A again? Well, it's at time 0 plus 3, right? So we have to add the value n, but then one more, because that means then it's going to be ready. So this will be at 0.3. Now, when can we run the next task A after running this one? Well, again, we have to add the value 3 to it. So add t equals to 6. And now what we want is we want to put these items into our heap queue, all of them. So we will put in the time when we can run it, including the label of the task into the heap queue. And then it might look something like, well, we're going to put in the time in the front of a small array. And this small array will contain the task name and the time when it's ready to be executed. Right. Now the next element, well, it's a heap, right? So the next element will contain maybe the next valid one, which would be, well, it could be 0b, you know. It could also be 3b. We don't know. It just matters that we have the minimum element here. And when we pop this element out, the heap property ensures that the next element that will be on top will then be 0b, right? That's guaranteed. So we're going to have to build this structure up. And one way to do that is, well, we're going to iterate over all of the tasks. So for task in tasks. And, well, we're going to compute its next execution time. And for that, we're going to use a little hash map that remembers the different times or the next time when a task can be executed. So the schedule is going to be default dict, and we're going to store integer values in that. By the way, these imports, you don't need them on LeetCode. They are automatically available to you. But if you're on any other platform or in any other environment, you probably have to import them. Now, what default dict does is that it returns by default a 0 value when you try to access a key in the dictionary. So the next execution time is going to be 0 for the first time that we try to look up when a task can be run next. And then, well, we're just going to update it with n plus 1 for the next time we run into the task. And now what we need to do is we need to append this to our little heap queue, which is currently only an array. We're going to put in the next, the timestamp, including the task. And finally, after all of this, we have to heapify our queue. So this now completes setting up the priority queue that tells us when to, in which order we can run the tasks. Right, so, well, what is now to do? Well, we have to compute how many cycles we need. And so, how do they call this in intervals? I would call them cycles. And in the beginning, we have used 0 cycles on the CPU. And after that, well, we're going to return them. Now, we need to complete all of the tasks. So we have to have a little while loop over our task queue, or that runs while we have items in our task queue. And now what we need to do is we need to check. Well, actually, cycles may be wrong. Maybe we should call this T for time, how much time we need. So at T0, well, we have to check first, right? Well, can we run the top element in the heap? And we access it with Q0, that gives us the top element, and then 0 gives us the time index, right? T next. And if that value is smaller or equal than T, then for sure we can run this task and we can just pop it off the heap. Heap pop and off our queue, that's it. Now we just increase T plus 1. That's pretty much it. And now if we run this, heap pop typo. So if we run this, we see that it passes all the test cases. However, there's another issue. What if n is extremely large? Well, our while loop will be running for quite some time, and we can optimize that. And the way to do that is we could check, well, if we still have items in our queue and the first element in the queue, the next task to run, has a time that is going to be larger than our T value is, we could just increase our t value by that difference right away. So t plus equals just the difference between the two. So this will make sure that we only have to execute our while loop for as many times as we have actual tasks. So I'll run this again. Passes, and if I submit this, it should pass as well. Right, so there you go. The trick is to order the elements in such a way that you can pick them off one by one. And then the other trick is to advance the timer so that the next time you run your while loop body, you actually can take an element out of it. Yeah, and strictly speaking, you can also remove this if you wanted to, but I'll leave it there. That's it.